Hello everyone, and welcome to another wonderful video with Mr. Roundy. Today's math topic is going to be on greatest common factor, one of the precursor skills for working with fractions. So, let's get started, shall we? Today's objectives. By the end of the video, you should be able to explain what a factor is, list the factors of a number, and find the greatest common factor of two numbers. We'll revisit these objectives at the end of the video. First of all, what is a factor? Well, the definition of a factor is whole numbers that can be multiplied together to find a product. However, for some people that doesn't really make a lot of sense. What does that mean? Well, I think it'll be easier if I just show you what factors are. So let's take a common multiplication problem and look at the pieces. So here we have 3 times 4 equals 12. Well, we know the answer to a multiplication problem is referred to as the product. So, according to our definition, whole numbers that can be multiplied together to find a product. Well, what we multiplied in this case was 3 and 4, which gave us the product of 12. Well, the factors in this problem would then be 3 and 4, with the product being 12. So, factors of the number 12 are 3 and 4. Now, there might be other factors for the number 12 as well, because there's probably other numbers that can be multiplied together to get us the number 12. But in this case, 4 is a factor and 3 is a factor of 12 because they can be multiplied together to get us 12. So now that we have a basic understanding of what a factor is, then what's greatest common factor? Sometimes we like to call it GCF for short. Really, all the greatest common factor is the largest factor that two or more numbers have in common. We have to figure out what the factors for those numbers are and then decide which one is the biggest of all those factors. Let's try practicing working with greatest common factor. We have here two numbers, 12 and 8. What we're going to do to find the greatest common factor is we're going to list all the factors of these two numbers. So let's start with 12. I think of all the numbers that can be multiplied together to get 12. So it's one of the first ones that comes to mind is 3 times 4. So 3 and 4 are both factors of 12. I can also do 2 times 6, meaning 2 and 6 are also factors of 12. I can do 1 times 12, and those are factors of 12. Sometimes I might miss a set, which can cause me to get the wrong answer if I miss the greatest common factor. What I usually do, instead of writing out all the times, is I just go through and I just start with 1. And I say, is 1 a factor of 12? Of course it is. 1 times 12 is 12. I say 2 is 2. Yes, 2 is a factor of 12 because I can multiply it with 6. 3 is, 4 is, 5 isn't. 6 is, 7 won't, 8 isn't, 9 isn't, 10 isn't, 11, clear up to 12. Next, I go to 8. I say 1, yep, 1's a factor. 2, yeah, 2 times 4. 3, nope, can't times anything with 3 to get 8. 4, yes, 4 times 2. And I know that 1 times 8 will get me there as well. 7 doesn't, 5 doesn't, 6 doesn't. Now I compare my lists and I see all the ones that they both have. So they both have a 2, they both have a 4, and those are the only ones in common that they have. So of those ones that they have in common, 4 is the biggest. So our GCF, or greatest common factor in this case, is going to be, is going to be 4. Let's try another one. So next, let's try the numbers 20 and 24. So I start thinking of all the numbers I know that can be multiplied to get 20. Now, does my list have to go in order every time? No, but it does help if it's in order. So I know that 4 times 5, so 4 and 5. I know that 1 and 20. I know that 2 times 10 are all factors of 20. 24, I think of the different combinations that can times to get 24. 1 and 24. I think of 6 and 4, 3 and 8, 2 and 12. Now I'm going to compare my lists. Notice that if I had done these in order 1 through 20 and 1 through 24, it would have been a little easier to compare. So they both have 1. They both have 4. They both have 2. And that's the end of our comparison. So I find the number that they both have in common, the factor they have in common that's the largest, is 4. So our GCF equals 4 once again. Let's see where we can use greatest common factor in a more real-life situation. Take, for example, Jim. Jim is selling t-shirts. He's selling University of Oregon t-shirts and Oregon State t-shirts. Now, he has 36 University of Oregon shirts, and he has 42 Oregon State University shirts. He wants to stack them in neat piles, but he doesn't want to have any of the shirts mixed together. So, he actually needs to find greatest common factor to tell him how many shirts to have in each pile. So, we start out by putting out how many shirts he has. Now let's find the greatest common factor. That will tell us how many shirts he needs in each pile. So we have 1, 2 factors of each of these. We've got 3 for 36 because it times with 12. We have got 4, which times with 9, and we've got 6, which multiplies with 6 to get us 36. And we also have 18, which times with 2 to get us 36. And the final one that we have is 36 itself, 1 times 36. 42 has 1, 2, 3, 6, 7. Now 1 times 42, 2 times 21, 3 times 14, 6 times 7. So there we have all our factors for 36 and 42. Now I'm just going to circle my common factors that I have in each one. We've got 1s in each, 2s in each, 3s in each, no 4s, but we do have 6 in each. 7, no. 42, no. 21, no. 14, no. So the largest one that we have in each is 6. So our GCF is 6. So when we make our piles, we're going to want to have piles of 6 t-shirts in each pile. Let's go back now and review the objectives for today's lesson. The objectives for today's lesson were to, by the end of watching this video, be able to explain what a factor is, list the factors of a number, and find the greatest common factor of two numbers. If you're having trouble with any of these things, please go back and review the examples that we showed in the video. I'm glad you could watch. Have a great day.